Alright, ladies and gentlemen, if you want to take out your homework to start with, these are the evens that were not given to you just so that you can see them for reference. And once you're finished, just please make sure you should have already submitted your homework, but if you could make sure that it's submitted because I'm not there today. And then if you could download the notes for today, which is 2.8. And if the sub could pause the video once everybody has the notes, either picked up from the sub or downloaded, we'll go ahead and get started. Alright, today we look at a important concept of what is an inverse and how do you know if a function will have what's called an inverse function. I think it'll be most helpful if we start with what does the word inverse mean. You probably already have some context to the word inverse. You might have heard of it as meaning opposite or to undo. That's probably the best way to look at it for looking at inverse functions. So just go ahead and write opposite / to undo. If you're looking at that and you're like, I don't remember hearing that word, let me take you back to your math background. And if we think of what's an inverse operation, here's some examples of inverse operations. Inverse operations, they undo each other. So if I ask you what undoes multiplication, you would say division. Multiplication, division are inverse operations. If I asked you what's the inverse operation of addition, you would say subtraction. If I asked you what's the inverse operation of a square, you would say a square root. Okay, now that we've looked a little bit at what an inverse means, let's take a look at an example of a function. So here's our function, and it's inverse. Now this is new notation. Go ahead and write inverse. That little f to the -1 power, that represents inverse. So this would be the inverse function. Okay, so we're going to take a look at, by using a mapping diagram, what we notice about a function and its inverse. Now, you haven't been taught yet how to find the inverse. You will be, but you could probably figure that out right here. This function is 2 times x. This function is really x divided by 2, or 1/2 x. So you notice the multiplication and division, they undo each other. Okay, now let's investigate something about the domain and the range of each. So I'd like you to, and if you are on OneNote, you'll want to use a different color. We're going to investigate certain values in the domain of this function and map them to their range. If I look at f of x, there's no square root, there's no fraction, so the domain is everything. Every value of x will produce a real number answer for y. But for our studying purposes, I want you to use values of -1, 1, 2, and 3. So go ahead and write those down, and now I need to ask you, if you plug in -1, remember domain are your x's or your inputs. If you plug in -1 for x, what will come out? 2 times -1 will give me -2. If I plug in 1, what will I get out? 2 times 1 will give me 2. If I plug in 2, what comes out? 2 times 2 gives me 4. If I plug in 3, what comes out? 2 times 3 gives me 6. So now we know with a mapping diagram, we map the corresponding inputs to the outputs. So -1 was mapped to -2, 1 was mapped to 2, 2 was mapped to 4, 3 was mapped to 6. Okay, now to study the inverse, what I'd like you to do is, again, if I look at this inverse, the domain is everything. I could plug in any number for x and get a real number answer out for y because there's no x in the denominator and there's no square root. But what I'd like you to do is to copy the same values that we saw in the range as the domain for the inverse. So copy the values -2, 2, 4, and 6. And now let's do the same thing we did with the last function. Let's plug them into the inverse. Half of -2 would give me -1. Half of 2 gives me 1. Half of 4 gives me 2. Half of 6 gives me 3. Okay, so -2 is mapped to -1, 2 is mapped to 1, 4 was mapped to 2, 6 is mapped to 3. Now, zoom out. Let's take a look at our answers. What do you notice about a function and its inverse? Oh, I could have called this, I could have said, hey, this is the range, because that's the y values coming out. What do you notice? Hopefully, it's pretty clear to you that the domain and the range are switched. That's the key idea. The domain and the range are switched. Okay, so let's investigate what type of a function has an inverse that's also a function. So every function has an inverse. You can always undo what's been done to x. But the question is, how do you know if the inverse is a function? Really, to understand this, we have to go back to, well, how do we know if something's a function? And we learned that in the last unit. For something to be a function, every element in the domain is mapped to exactly one element in the range. In birthday terms, remember we looked at people being the inputs, birthdays being the outputs, and we said every person has to have a birthday. In math terms, that means every input has to have an output. We said no person can have more than one birthday. In math terms, a condition for a function would be no input could have more than one output. And then lastly, number 3, more than one person can share a birthday. In math terms, that would mean more than one input could share an output. Remember, so you could have multiple arrows coming from one x. In fact, some of us are more visual. I'll just kind of show what that looks like. Like you could have multiple arrows coming to the same y, right? More than one person can share a birthday. Okay, how can we tell if a function has an inverse function? Here's the answer. In math terms, we would say if a function is 1 to 1. What does that mean using our birthday language? That would mean that we would have to change number 3 above. This can no longer happen. Okay, I'm a little confused because I accidentally must have pressed the record button. Now I'm not sure where I was. Okay, let's just make sure that we got this down. Old information, the vertical line test determines if a graph is a function. New information, the horizontal line test is going to determine if a function is 1 to 1. So if the horizontal line passes more than once, the function will not be 1 to 1. Let's go ahead and try example 1. Example 1, x minus 2 quadratic cubed. We know that the minus 2 inside the parentheses is going to move the function. How? Hopefully you're thinking right 2. So I would go take my original graph. Remember our original graph looks like this. I'm just going to go right 2 units. 1, 2. Move all those other points right 2 units. And there's my new graph. If I look at, does it pass the vertical line test? Yes, it is a function. Does it pass the horizontal line test? Does the horizontal line pass the graph only once? Yes. This function is 1 to 1. On to example 2. Example 2, this is a parabola. And if I look at how does it move, it goes to the left 3 units, and it goes over, reflects over the x-axis. So I would take my parabola, which looks like this, and go left 3, 1, 2, 3. And then I would flip it upside down. Oh, actually, you're supposed to go upside down first and then left 3. But in this case, you end up getting the same graph. So I'll just go ahead and flip that down. Okay, now if I look at is this graph 1 to 1? Is it a function? Yes, it passes the vertical line test. Is it 1 to 1? Meaning, does it have an inverse that is also a function? And the answer is no, not 1 to 1. And if you're thinking about it, you could look at any ordered pair. Like if I look at the ordered pair, even if I did the vertical line test up here at -2, -1, and this one would be at -4, -1. Notice that they have the same y, and that's what we can't happen for a function to be 1-to-1. All right, let's investigate inverses in a little bit more depth. Woo! Okay, here's a function, and here's what's defined to be its inverse. Let's do some investigation. Evaluate each of the following. What would be the function at 6? Well, 2 times 6 plus 4. 12 plus 4 gives me 16. Now I want you to purposely go across. If I look at what's the inverse of 16, I'm going to plug in 16 for x. Half of 16 minus 2 would give me 6. Okay, I'd like you to pause the video and see if you can finish the rest. Okay, hopefully you saw the pattern that when you plugged in an x value into the function, you got an answer, and if you plugged in that answer into the inverse, you're going to get back the original x. In fact, I should probably put these in different colors. So, for example, I plugged in 5, and I got out 5. Okay, so that's going to help us answer this last one. If f of x is going to give us y, if I plug in that y value into the inverse, I'm going to get back x. That's the key idea of the inverse. The x and the y's have been switched. So if I plug in a y value into the inverse, I'm going to get back the x. That's going to help us in actually finding the inverse. So far, I've given you functions and their inverses. Now it's your turn to find them. So here's some steps to finding the inverse. Number 1, you're going to switch the domain and the range. Switch the x and the y. So if I look at this, we know that this is the same as y equals 3 times x minus 2. If I'm finding the inverse, the first step I'm going to do is switch the domain and the range. Switch the x, switch the y. So I have x is equal to 3y minus 2. Step 2 is we always solve for our output. So we're going to solve for y. So step 2, how do I solve for y? Well, I need to get rid of this minus 2 first. So I'm going to add 2, and that'll give me x plus 2 is equal to 3 times y. Divide everything by 3, and there's my answer for y, x plus 2 divided by 3. Step 3, well now we've found the inverse function. So step 3 is replace y with the correct notation. So I would have x plus 2 divided by 3 is what was found to be the inverse function. Or you could flip that around and say the inverse is equal to x plus 2 divided by 3. Okay, so that's our answer. Now let's make some connections to what we did on Friday, or last week. Letter B, I'd like you to find f of 2 and the inverse at 4. So if I find f of 2, remember this is our original function. So f of 2 will give me 3 times 2 minus 2. F at 2 is going to give me 6 minus 2 gives me 4. So f of 2 gives me 4. Now, if I find the inverse at 4, I found my inverse function to be this. So I'm going to plug that in. 4 plus 2 divided by 3. 6 divided by 3 gives me 2. So the inverse of 4 equals 2. Okay, now find the function of the inverse of 2. Remember, this does not mean multiplication. This means we have a function inside of a function. So this is the same as taking f of the inverse of 2. So we need to evaluate the inverse of 2 first. So let's go ahead and determine what is the inverse of 2. So I'm going to go ahead and plug that in. And the inverse is x plus 2 divided by 3. So I'm going to plug in 2 for x, and I would have 2 plus 2 divided by 3 is going to be the answer to the inside. So I'm going to say 2 plus 2 divided by 3 gives me, actually, you know what, guys? I'll go ahead and change this on yours. I meant for this to be a 4, so I'll change that on yours. Let's go ahead and, you could still do it with 2, but it's going to be easier for us to see the connection if we plug in 4. So, same thing. We have the function of the inverse of 4. And I'm going to determine what is the inverse at 4. So I plug in 4 in for my inverse, and that would be 4 plus 2 divided by 3 is going to be my answer. 4 plus 2 is 6. 6 divided by 3 gives me 2. Now I want to determine what is the function at 2. And we've already found this, but just for making connections, I'll plug it in again. 3 times 2 minus 2 gives me 6 minus 2 gives me 4. So let's put our answer. That's our final answer. So we know f of the inverse at 4 equals 4. Voila. Okay. Now let's go ahead and find the inverse of the function at, I'm going to change this on yours too, what would make it pretty easy to figure out. Let's do, do 7. Okay, so we're going to erase that. We're going to call it 7. What's the inverse of the function at 7? Well, I know I need to determine what's the inverse of f at 7. And I'm going to plug in 7 into my original function. So my original function was 3 times x minus 2. So 3 times 7 minus 2. I didn't do this right, but that's okay. So I have the inverse of 21 minus 2 will give me 19. And then I'm determining what is the inverse of 19. So I would have 19 plus 2 divided by 3. And 19 plus 2 gives me 21. 21 divided by 3 gives me 7. So the inverse of the function at 7 gives me 7. Okay, hopefully you're noticing that if you plug in a value to the inverse and then the original, whatever was done to the x undoes it. So notice, the function of the inverse at 4, we get back 4. The inverse of the function at 7, we get back 7. So now, the inverse of the function at 120, you could go ahead and do it, but I know the answer is going to be 120. And that is seen here in this little box. If you look at the inverse of the function at x, and remember this is the same as saying the inverse of x gives you x. Spits out the same x value. Okay, we're going to practice one more, and then you guys can go ahead and start working on homework. The principle of interchanging x and y to find the inverse function also gives us a method of obtaining the graph of the inverse from the graph of f. So what this is saying is that if you are ever graphing an inverse, any point on the graph, like let's go ahead and see, well, let's call this 2, 0. Since the domain and the range of the graph are flipped, the x and the y's are flipped, you will have the 2 becoming the y and the 0 becoming the x on the inverse graph. So notice, this point, if I looked at where does it line up, would be at 0, 2. We could follow that same method for every point, which is why they have A, B, B, A. And you will get the graph of the inverse really reflected over the line y equals x. Okay, let's go ahead and take a look at how we could do that. Here in number 2, sketch a graph of the function. I know that this is going to move to the right 2 units. So I have 2 units to the right, and this is, well, okay, if you're thinking about the original parent graph, it would be like 0, 0, 1, 1, 4, 2, and you would go like this. You guys did great on your test, so I know that you'll do good with that. And then move it to the right 2. 1, 2, 3, 4, 2. And then just for helping us graph, let's label these points. This point moved to 2, 0. This point moved to 3, 1. And this point moved to 4, 2. If I was to graph the inverse, so this is my function, if I was to graph the inverse, I would switch the x and the y's. So instead of writing 2, 0, I would plot 0, 2. Instead of plotting 3, 1, I'd plot 1, 3. And instead of plotting 4, 2, I'd plot 2, 4. 1, 2, 3. Oh, that's not 4, 2. Sorry, I graphed that wrong. That's 1, 2, 3, 4, 5, 6, 2. There we go. That looks better. So instead of plotting 6, 2, I'd plot 2, 1, 2, 3, 4, 5, 6. And then I'd continue in the shape that all the other points would follow, and we can see the graph of the line, or the graph of the function and its inverse, being reflected. What is it reflected over? This line right here, which is right down the middle. And if you think about what is that line, it has a y-intercept of 0 and a slope of 1, up 1, right 1, up 1, right 1. So that's y equals 1x plus 0, or you could say y equals x. Okay, and then just to conclude, let's practice finding the inverse one more time. So if I look at this function, it says find an equation of the inverse. Remember, this is the same as y equals square root of x minus 2. Step to finding the inverse, if you need help, you can reference the steps up here. But number 1, we need to switch the domain and the range, so switch the x and the y. So now we have x is equal to square root of y minus 2. Step 2, solve for y. So I'm going to square both sides. And I have x squared is equal to y minus 2. Add 2 to both sides. And I have x squared plus 2 gives me y. Finally, step 3, replace it with good notation. So this is my inverse function, so I'll call it inverse of x is equal to x squared plus 2. Lastly, you might be looking at this saying, well, wait a minute, this is the inverse, how come there's only half of x squared plus 2, like if I graphed the other half? Technically, this function has an adjusted domain. Remember, the domain and the range of the function and the inverse are switched. So if I asked what's the domain of the original function, where does the x value start? They start at 2 and they continue to infinity. What's the range of the function? Where do the y values start? They start at 0 and go to infinity. Which means the inverse domain and range are going to be flipped. So the domain is going to be 0 to infinity, and the range is going to be 2 to infinity. So technically this is the inverse with this domain. But in your homework you will not have to find the domain. If you see it in your book, maybe you know what it's referencing now, you will just have to find the inverse. Okay, you guys can go ahead and start the homework.